What is up, everybody? Welcome back to another math video brought to you by the Mathnasium. And today we are going to be getting two more exponent rules with which we'll be able to solve and simplify exponential expressions. So let's go ahead and jump right in with some really basic examples. So we're going to kind of jump in the way back machine. We are going to travel back in time to when we were simplifying fractions at the beginning of the year. And I said back in the day, when you were simplifying fractions, a lot of times your teacher would tell you, hey, well, we're going to simplify 25 tenths. Well, 25 and 10 are both divisible by 5, so we could divide the top by 5, and we could divide the bottom by 5, and then it's magically what it's supposed to be, okay? Why can we do that? What allows us to divide the top by 5, divide the bottom by 5? You guys didn't like Slagle's method for simplifying, but I still like it. Okay, I'm gonna describe to you why we're allowed to divide the top and bottom by 5, and it is that knowledge and understanding that's going to help you with today's exponent rules. So rather than doing the division, you can think about taking these numbers and factoring them, which means writing them as a product of other numbers. And sometimes we can break them down into a prime factorization, which is as factored out as possible, but we don't always have to. So 25 broken down is 5 times 5. We cannot break apart 5 any further. And then 10 factored is 5 times 2. Now, you may have also seen this and me do this before, but we're allowed to kind of just cross off the 5 in the top and the 5 in the bottom. And that is exactly the same idea as dividing the top and bottom by 5. And we're left with our answer, 5 over 2. 5 over 2 is this fraction in simplest form. So why are we allowed to do this? Why are we allowed to cross things off? Okay, it has to do with the fact that I could take 5 times 5 over 5 times 2, and I could write it as a product of these two fractions. This would be the same, right, as up there. Well, 5 over 5 is just 1. And so what we can do is really pull out any number over another number and turn it into a product of fractions. But I'm not going to do this every time because it's a waste of time, right? It just turns to 1. And then we have 5 over 2 left over. So if we're simplifying 3 over 24, what do we do there? Well, 3 goes in the top. We can write the prime factorization of 24 in the bottom. If you want to break that apart, you can. 6 times 4, which is 2 times 3, and then 2 times 2, which is 2 times 2 times 2 times 3. And then our 3's cancel, and we are left with 1 over 8. 2 times 2 times 2 is 8. Now, if you were really clever here, you could have said, hey, why don't I just break apart 24 so that there's a 3 in the factoring? 8 times 3 is 24. Cancel, cancel. 1 over 8 also works. So this is the act of simplifying a fraction, which is basically what we're going to be doing today, except the fractions we're going to have aren't really going to have numbers. They're going to have a whole heck of a lot of letters. And so we're going to see some basic examples of that first. So we're going to start seeing simplifying fraction with variables. And we're going to be using this technique of writing out a product, canceling, to discover our first rule. So we kind of talked about this already. Any number divided by itself is equal to 1, okay, with the as long as x is not equal to 0. X cannot be 0 here. But every other number, when you divide it by itself, it's equal to 1. Okay, how about right here? X to the 5th over x to the 3rd. So let's think about that. That is 1, 2, 3, 4, 5. I'm going to use expanded notation here for us to think about this. This is not how I expect you to do the problem on your assignment, but it helps us to understand the rules and where they come from. And then 1, 2, 3x is being multiplied on bottom. I can then go through and every pair of x's that's in the top, or every single x, every pair of x's that's in top and bottom, I can cross off that pair. So x cancels with x cancels with x cancels with x, and we're left with 2 x's in the top in the numerator, which gives us x to the 2nd over everything canceled on the bottom, So we can put a 1. So this in simplest form is just x squared. Great. All right, how about this example in green down here? I know this is arduous, it's awful, but at the same time, it's this awful process and writing out what this truly is that actually helps us to understand what's going on. 5, 6, 7, 8. We are not starting a dance number. I just started counting like that because those were the numbers I was counting. Okay, cancel. It doesn't matter which one it cancels with, right? I could cancel with any old x in the top and any old x in the bottom. 4 in the top are going to cancel with 4 in the bottom. And our final answer will be 1 over x to the 4th. Multiply what's left. 1, 2, 3, 4 are left. That's our answer here. Okay, let's take a second to think about this. What is rule 6 then? So we had 5 x's in the top, 3 in the bottom. We ended up with 2 in the top. We had 4 in the top and 8 in the bottom. We ended up with 4 in the bottom. It would appear that the number that remains is always the difference between the top and the bottom. And whichever side has more, that's where they end up being when we're done. Oh, you can't even see the original problem. I'm very, very sorry about that. Let me drag that out. There, Slagle. Come on, team. Come on. All right, so, yeah, that's what we got going on. X to the 4th over x to the 8th. We have x's in the bottom and in the top, depending. So whichever one has more is where it's going to end up. Perfect. So 5 minus 3 will give us a 2. 4 minus 8 will give us -4, which then will go to the bottom and become 4 if we're talking about a difference. What operation are we doing with these exponents? Subtraction. So here is the rule. Here's the rule in all of its glory. All right, and I'm actually going to add a little bit here. It says that whenever you have a base in the numerator and you're dividing by the same base in the denominator, we can subtract their powers. Ooh, that's exciting. And then, yeah, so m minus n. So if we can actually, it's actually happening in the numerator. It's a to the m minus n over 1. So really the reason behind that, if you wanted to see why that's happening, is I could move this up to the numerator, but then its exponent would have to become negative. So when we come this way, a to the m plus negative n, and then we're back to where our answer, right? It's m plus negative n is the same as m minus n. And again, we're kind of moving that over 1. All right, so what this allows us to do is this allows us to do this kind of math very, very quickly. So when you see 10 to the 4th over 10 to the 2nd, do not multiply out 10 tens and then divide them. For heaven's sake, let's go ahead and just use this rule. We can say, all right, in the numerator, this is 10 to the 4 minus 2 over 1, which is 10 to the 2nd over 1, which is just 100 over 1 or 100. We really don't need this over 1. The reason I'm writing that is that you see that the base goes to the top, and that's where we do top minus bottom. So there's our rule 6. Take a minute to write that on your rule sheet. All right, let's keep cruising. Let's see some simpler examples here. Y to the 8th divided by y to the 15th. Look, you don't want me to write out 15y's and 8y's and cross them off. It's a waste of your time. So let's just apply the rule. This is y to the 8 minus 15 in the numerator. Y to the 8 minus 15, which is y to the negative 7. And so we can now, since this is a negative exponent, we want to move it down to the denominator to keep all of our exponents positive in our answer. That's what we're looking for. Okay, let's do a couple more examples. I'm going to pause and write them out for us. All right, go ahead and give this one a shot and then pause the video and we can check our answer here in just a minute. All right, I'm going to go. It's time to go. It is time to get her going. We're purple. Here we go. So we're going to do 15 to the, or sorry, x to the 15 minus 23, x to the 15th minus x to the 23rd, which is going to give us x to the negative 8th in the numerator over 1, which means we have to move that down to the denominator, which is 1 over x to the 8th. Okay. Getting stoked. Stoked for Mandalorian Season 2. Boy, that is, maybe that will not age well later on my YouTube channel. Hopefully it's not a flop. Okay. All right. So here, it's not one base, it's 2. So if you really wanted me to write this out, I could, right? I could sit here and write. I have a single 2. I have 8 x's. 4, 5, 6, 7, 8. This is a pain to do, right? 2 times 2, and then x, x, x. I could go through and cancel all these out, but it's the same process. It's going to be the same, so why waste our time? Let's see if we can get the answer first. 2 in the top, 4 2's in the bottom. 1 pair of 2's is going to get canceled. We're going to have 3 left in the bottom. 8 x's in the top, 3 in the bottom. 3 are going to cancel in the top. We'll have 5 left in the top. So let's go ahead now and let's use this rule number 6. Let's use this to, you can come downstairs. It's fine. We got Gandalf here. We already got a whole party. Okay, so you can write the 2 bases. There's 2's and there's x's, and so we can do top minus bottom is going to be 2 to the 1 minus 4. Careful, there's a 1 there. If it helps to write it, then do that. And then x to the 8 minus 3, which is 1 minus 4 is 2 to the minus 3. X to the 8 minus 3 is 5. All right, and then remember this is happening in the numerator, so I'm going to bump that on down to the bottom, and we'll have x to the 5th over 2 to the 3rd, but we're not done yet because I want to know what 2 to the 3rd is. So it's x to the 5th over 2 to the 3rd is 8. Oh, that's so nice. So nice. Okay, and then this one in red, and then I'm going to have you guys tackle the one in blue. All right, the one in red, I'm going to apply that same rule. Remember, this is happening in the numerator. Sometimes I'm writing over 1 right here. Sometimes I'm not. I'm just kind of mixing it up. It doesn't really matter. If it helps to write the over 1 thing, let's do it. So here we're going to do x, and then we do to the top minus the bottom. Be very careful here, because it's negative 4 minus negative 10. You have to include the subtraction sign from rule 6 plus the additional minus sign from the 10. All right, and that's over 1. So in the numerator, we have x to the negative 4 plus 10. I'm going to go ahead and change the sign over 1, which is x to the to the 6th, and that's it. We don't need to write over 1. We're all done. X to the 6th is all it is. We don't have to shift anything around. We don't have to write over 1. In fact, that makes things more complicated. Just leave it. X to the 6th. Okay, you try this one in blue. I'm going to come back in just a minute. Okay? Here we go. All right, it doesn't matter the order that we multiply. So, like, we can, if there are 7 3's in the top and 5 3's in the bottom, doesn't matter which side. You can just swap them with y to the 11th or y to the 4th or whatever you want to do. So basically, we can just start with our 3. I always start with my number. So 3 to the 7, top minus bottom, 7 minus 5, y to the 4 minus 11 is going to give us 3 squared, y to the negative 7th. Okay, I'm going to put 3 squared in the top. 3 squared is 9. And y to the negative 7th is going to go to the bottom and become positive. Super. All right, let's take a look at these two monsters. When you have a ton of variables present, you have many, many, many variables present, I would highly recommend just thinking about 4 over 30, the fraction, to simplify. So how do I simplify 4 over 30? Well, you can do it the way we did it at the beginning, where you break down and factor them out and cancel, or you can use your old method that works too. So 4 over 30 simplifies to the fraction 2 over 15. Now, in the top of this fraction is where I'm going to do my subtraction. So it is x to the 13 minus 6 for x. There's no other x's, so we're good. And then it really helps to double check and make sure everything is simplified. We can't combine any, so we're good. So 13 minus 6, y to the 2 minus 3, z to the 1 minus 8. And w is negative, and there's nothing subtracted in the bottom, so I'm just going to move that down right now and just kind of use that as part of this step. Okay, and now we can simplify. We'll end up here with 2 over 15, and then x to the 7th, which is positive in the top, y to the minus 1, 2 minus 3, z to the minus 7th. So, and then anything that's negative we need to move, so we'll end up with 2 over 15, and then we'll have x to the 7th in the top, and y to the 1st, z to the 7th. Slagle, what are you doing? Taking the ring to Mordor. That's what I'm doing. Okay. 2 over 15, x to the 7th, y, z. I think we're good. All right. So let's just check our work here. Let's check our work, the work in black. If we're thinking about this logically, you can look right here and kind of see your answer. Forget the 4 over 30. 6 x's in the bottom are going to cancel with 6 x's in the top. There will be 7 left in the top. Oh, look at that. Hey, 2 y's in the top are going to cancel with 2 y's in the bottom. There will be 1 left in the bottom. Hey, look at that. 1 z in the top is going to cancel with 1 z in the bottom, so there will be 7 left in the bottom. Hey, look at that. W to the minus 2. What happened to w to the minus 2? Aha! I caught it. Look at that. I did it. I did it. No one caught me. I found the mistake myself. You guys were probably just watching in agony as this train wreck, Slagle the train wreck, started barreling. And that's why we check our work, folks. I was actually testing you to see if you were paying attention. Perfect. Yeah, I'm glad we did that. That's great. All right, so now we can go back through. W moves to the bottom. I forgot. I can't believe I forgot. W, I'd never forget you. I won't. I'll always come back for you. I promise. X to the 7th, and then we have a bunch of junk going on in the bottom. Super duper. That's looking great. Probably did that in class too. Sorry, guys. Whoops. Okay. And then over here, I want you guys to try this one. Don't forget your W's. Just kidding, there aren't any. You can pause the video, give it a shot. And we're going to go ahead and get started. All right, 3/9 simplifies to, it's this easy, 1 over 3, x to the, watch those negatives. Stay on target, 4 minus negative 3. Y to the negative 2 minus 4. Stay on target, 4 minus negative 10. Bingo. No W's? Slagle, what a goof. What a goof. That'll be x to the 4 plus 3, which is 7. 4 plus 3 is 7. And then y to the, double checking here, y to the negative 6th, z to the 14th, which will end up being, and then over 3. So all we got to do is shift that y down to the bottom, which would be x to the 7th, z to the 14th, all over 3 times y to the 6th. Wonderful, 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 wonderful. Absolutely wonderful. Okay. Great. All right, next one. Hopefully that went well for you. Some of these are going to be pretty messy. Pretty messy, I tell you. So what I would recommend you do before you begin that process of doing the x top minus bottom, make sure the top and bottom are as simple as they can be. So step one here is for us to simplify that top. And there are many different strategies or orderings in the way that you could do things in this problem. But I'm going to simplify the top, which means I really have to focus on making sure I raise both bases to the minus fifth power. So it's going to be 4x squared times x to the 3 times negative 5 is negative 15. And then y to the negative 2 times negative 5 is positive 10. In the bottom, I have 12y to the minus third. I don't want to do... I guess we can kind of tackle both of these at the same time. So 4 over 12 simplifies to 1 over 3, so we can have that, bring that down. And then we have x to the second times x to the 15th. Those are on the same side, so we can actually add their powers. That's 4 plus negative 15. They're on the same side of the fraction, so we're good. And then the y's are on opposite sides, so that was applying rule number 1. Now we're applying rule number 6, the one we learned today, which will be 10 minus negative 3. All right, simplifying further. We don't need to write 1 times because 1 times anything is just itself. So you're going to have x to the negative 13th, y to the 10 minus negative 3 is y to the 10 plus 3, which is 13 over 3. So then all we got to do is bump that x term down, and we're done. Bingo. Hope I did that right. Positive 10. Double checking our work. Slagle's tired. Yeah, looking good. Looking good, folks. All right, rule 7. So what do we do when we have a fraction raised to a power? So to think about this, and if you forget, I invite you to just draw up a little fraction and check, right? What's the definition of an exponent? It says we take that thing and we multiply it, 3 of them in a product. Okay, great. Well, with fractions, you multiply across the top, you multiply across the bottom. So actually, I'm going to write this over here. You end up with x times x times x, which is x to the third, and 3 times 3 times 3, which is 3 to the third. So what's the rule? Well, I could have just saved a whole lot of time instead of writing that out. How about we just raise each of these to the third power? Aha! Careful there. I saw you. You guys were like, oh, you guys were going to say it's x to the n over y to the n. And you would be correct. But I'm going to add this little caveat. I want you to put parentheses around both of those variables. So I'm actually going to rewrite this a little neater. I want you to prevent forest fires. I want you to prevent forest fires and to put parentheses around problems like this. Okay? And I'm going to show you why here in a second. Here's why. Let me tell you why. I'm going to tell you. Here's why. Make sure you use those parentheses. I'm going to do this one in black. And then here's what people do. If they don't put parentheses, this is what people do. They just go, oh, it's 3x squared over 2y squared. Done. Incorrect. Not going to work. You have to square everything in the top. And so to help yourself remember, I'd like to invite you to imagine yourself taking a scissors and just kind of cutting those parentheses. Maybe they're like rubber bands and they're like, they just like go up and wrap the top and wrap the bottom. Keep them parentheses around. Don't forget. Whatever silly trick helps you remember. 3x squared over 2y squared. Both of them should be raised to whatever power is written right there. All right, and now we're going to It's not the distributive property, but it's similar. We're going to make sure each base on the inside of these parentheses is raised to that power. So that's going to be 3 squared x squared over 2 squared y squared. So we end up with 9x squared over 4y squared. Oh, ho, hoo. Everything covered up? No, we're good. All right, cool. All right. One thing you need to be careful of is you need to make sure before you begin, before you make things more complicated, you want to make them as simple as possible. Don't go ahead and make things complicated and then try and make them simple. Bad idea. Because, just simplify the inside of the parentheses before you use rule number 7 is what I'm trying to say. So here on the inside, it's maybe not super clear what we need to simplify. Take a second, see if you can spot it. Unpause the video. Unpause. Here we go. X is in the top and in the bottom. So what we're going to do is 2 x's in the bottom. We're going to cancel with 2 x's in the top, and we'll have 1 x left. So it'll be x to the 3rd over 3y to the 4th. And then the x's are gone. I don't know why I wanted to write them. I felt the need to, but I didn't. X to the 3rd, we're going to cut them parentheses, turn them loose, and you get that there. X to the 3rd is just x to the 3rd. Now we got 2 bases on the inside of the parentheses here. Again, the x went away because they canceled with the ones in the top. And you'll have 3 to the 3rd, y to the 4 times 3, which is 12. So we end up with x to the 3rd over 27y to the 12th. Beautiful. It's looking nice. Looking nice. Last one. I bet you can. I bet you can do it. I bet you can do it. Make the inside simpler before you make the whole problem more complicated. So simplify the inside, and yes, it can be simplified. Hoi, hoi, hoi. Refreshing. All right, unpause the video. Simplify 3/18. 3/18 simplifies to 1 over 6 if you divide them both by 3. And then in the top, x to the 3rd is negative, so I'm going to bring that down to the bottom. In the top, I'm going to do y to the 6 minus negative 2. Top minus bottom goes to the top. And then z to the 3rd is positive in the bottom, so I'm just going to leave it down there. And we're squaring. 1 times that. Let's still simplify the inside a little bit. 6 minus negative 2 is going to be y to the positive 8th. And then 6 x to the 3rd, z to the 3rd in the denominator. I'm now going to apply rule 7. And I'm going to split up them parentheses and raise the top and the bottom to that 2nd power. Y to the 8th to the 2nd power is equal to y to the 16th. Multiply. There are 3 bases in the denominator, so 6 squared is 36. X to the 3rd squared is x to the 6th, and z to the 3rd squared is z to the 6th. Take a bow. Take a bow. Gandalf, you've done it. You did it. You're no longer Gandalf the Grey. You are now Gandalf the exponential math nerd. That's what your new title will be. Mithrandia. Okay, yeah, it's in Myopenmath. One thing I want to say for sure. Your problem is not simplified until all numerical expressions are evaluated. What do I mean by that? If you are writing something and you have 3 squared, don't leave it as 3 squared. You need to turn that into 9. Okay, that needs to happen. There shall be all positive exponents. Okay, if there is an exponent in your expression, it should be positive if you want your expression to be simplified. Or there shall be no negative. If you have a negative exponent, you're not done. Lastly, each base written once, so you know it's simplified. So this would be like x to the 4th, y to the negative 2nd should be written as x to the 4th over y to the 2nd. Each base is only written once, so if you have like x to the 3 times x to the 2nd divided by x to the 9th, that would be x to the 3 plus 2 minus 9. You want to combine them all into one x. 3 plus 2 is 5, minus 9 is x to the negative 4. No negative exponents, cheater. 1 over x to the 4th. So that's this step here. Each base is only written once. And fractions should be simplified. So I guess that falls under that. Like if it's 4 over 6 and you have like x over y, please make sure that that is 2/3 y. So simplify all those fractions. All right, team. That's it for this video. It's quite a long one. Thanks for watching. Hope it was helpful. We'll see you at Mount Doom.